Black holes are among the most fascinating and terrifying objects in the universe. They're invisible, mysterious, and powerful enough to warp time, trap light, and possibly connect different parts of the cosmos. But what actually is a black hole? Let's break it down, starting from the beginning. To understand black holes, we first have to talk about gravity. Gravity is the force that pulls objects toward one another. It's what keeps the moon orbiting the Earth, the planets orbiting the sun, and us anchored to the ground. The more massive an object is, the stronger its gravitational pull. Now, imagine an object so massive and packed into such a small space that its gravity becomes unstoppable. That's a black hole. Most black holes form when a massive star runs out of fuel. Stars are held together by the balance between two forces, gravity pulling inward and nuclear fusion pushing outward. As long as the star is burning fuel, it resists collapse. But when it runs out of fuel, that balance breaks. The core collapses under its own gravity. If the star is big enough, at least 3 times the mass of our sun, nothing can stop the collapse. The core gets crushed into an extremely dense point called a singularity, and a black hole is born. So what is a singularity? It's a point in space where all the mass of the star has been compressed into a zero-volume space. That means it has infinite density. All of space and time as we know it cease to function normally here. It's a place where the laws of physics, especially general relativity, completely break down. We don't really know what happens inside a singularity. It's one of the biggest mysteries in modern science. Now, surrounding the singularity is something called the event horizon. This is one of the most important features of a black hole. It's not a surface or a wall. It's an invisible boundary. The event horizon is the point at which escape becomes impossible. If you cross it, no matter how fast you try to move, even at the speed of light, you'll never be able to get out. It's literally the point of no return. From the outside, black holes appear completely black. Since light can't escape, they don't shine or reflect, but we can detect them indirectly. One way is by observing how nearby stars move. If a star seems to orbit around empty space, it's likely circling a black hole. Another way is through X-rays. When matter falls toward a black hole, it forms a disk called an accretion disk. This matter gets heated to extreme temperatures as it spirals inward, emitting powerful X-rays that we can detect with space telescopes. Now, not all black holes are the same. In fact, there are several different types. First, we have stellar mass black holes. These are the most common and form from collapsing stars. They usually have a mass of about 3 to 20 times that of our Sun. Then there are supermassive black holes, which sit at the centers of galaxies, including our own, the Milky Way. These can have masses ranging from millions to billions of times the mass of the Sun. How they form is still an open question. Some scientists think they grew slowly over billions of years by merging with other black holes and consuming stars and gas. Others believe they might have formed directly from massive clouds of gas in the early universe. There are also intermediate black holes with masses between stellar and supermassive ones. We've only found a few candidates so far, but they may help explain how supermassive black holes grew so large. Finally, there are primordial black holes, purely theoretical ones that may have formed just after the Big Bang. If they exist, they could help explain dark matter or the structure of the early universe, but we haven't found definitive evidence for them yet. Let's talk for a moment about time. Black holes don't just bend space. They warp time, too. According to Einstein's theory of general relativity, time slows down near a massive object. Near a black hole, this effect becomes extreme. If you were to hover just outside the event horizon, time would pass much more slowly for you than for someone far away. You could spend minutes near the black hole, while years pass in the rest of the universe. This is not science fiction. It's a real, measurable effect, and it's one of the most mind-bending aspects of black holes. But what happens to objects that fall in? As matter gets pulled into a black hole, it speeds up and heats up, releasing intense radiation. But once it crosses the event horizon, it's gone from our universe. Forever? That's a topic of debate. According to classical physics, yes, it's lost. But quantum mechanics throws a wrench into that idea. This brings us to one of the biggest mysteries in physics, the black hole information paradox. According to quantum theory, information can never be truly destroyed, but black holes seem to do exactly that. They swallow information and never give it back. Stephen Hawking proposed that black holes do emit something called Hawking radiation, a slow release of particles that causes black holes to evaporate over billions of years. The problem is, Hawking radiation appears to be completely random. It doesn't carry any of the information about what fell in. If that's true, it would break the rules of quantum physics. But recent theories suggest that maybe information isn't lost. Maybe it's encoded in subtle changes in the event horizon. Or maybe it leaks out slowly in Hawking radiation in a way we don't yet understand. Some even suggest that the black hole acts like a kind of cosmic hard drive, storing information on its surface. And then there's the idea of wormholes. Could a black hole be a gateway to somewhere else? The equations of general relativity allow for the possibility of wormholes, shortcuts through space-time, and some solutions even suggest that black holes could connect to white holes, which eject matter instead of pulling it in. But these are just ideas, not confirmed realities. If wormholes do exist, they'd likely be unstable or require exotic matter to keep them open. The truth is, black holes are a frontier. They're the place where our understanding of physics hits a wall. We've learned an incredible amount about them over the last century, but we still don't fully understand what happens inside. That's why scientists are building better telescopes, studying gravitational waves, and running computer simulations to probe these cosmic mysteries. In 2019, the Event Horizon Telescope captured the first ever image of a black hole's shadow in a distant galaxy called M87. It was a blurry, glowing ring, the silhouette of a black hole's event horizon against the glowing plasma around it. That image was a monumental achievement, and it's just the beginning. So, the next time you look up at the stars, remember, somewhere out there are places where the rules of space and time completely collapse. Black holes, born from dying stars, feeding on light, warping reality, and maybe, just maybe, holding the secrets to the universe itself. Thanks for watching. If you enjoyed this deep dive into black holes, give the video a like, subscribe to the channel, and hit the bell so you never miss a new space episode. Let me know in the comments what space mystery should we explore next. Until then, keep looking up, and stay curious.